Okay. Bismillah ar-Rahman ar-Rahim. We'll start now this 2.5, infinite limits. What do I mean by infinite limits? It means if the limit as x goes to a of a function f goes to infinity. Means what? You know, the values of f(x) can be made arbitrarily large as we please. And the same thing goes to minus infinity. It means the values of f(x) can be made arbitrarily large and negative by taking s sufficiently close to a. Okay. So accordingly, we define what's called vertical asymptotes. So we say x equal a is a vertical asymptote when that will happen if either x goes to a goes to infinity, or goes to a from left or from right, goes to infinity or minus infinity. Any one of these 6 conditions or 6 statements, if any one of them is true, then we say x equal a is a vertical asymptote. Now, if I have function over function, if I have function over function, function over function, so usually the possible vertical asymptotes comes from g of x equals 0. I find the 0 in the denominator. These are the possible ones. Not always they are vertical asymptote. However, if g of x make it g at a, let's say a possible vertical asymptote x equal a. If g at a, give me 0. And for sure, it will be a vertical asymptote إذا كان f of a not equal to 0. So if I have non-zero over 0, for sure I'm getting either infinity or minus infinity or does not exist. So for sure I have vertical asymptote if I have non-zero over 0. Now about the infinity, if the limit goes to infinity, the sum and another, if the limit of a function f goes to infinity and then the limit of another function goes to L, the sum L plus infinity is infinity, or L minus infinity is infinity, is minus infinity, or infinity plus L, this is infinity, infinity minus L, this is infinity. Now, this is for the sum or the difference. For the product, if you have the product of L times infinity, then it depends on L. If L is positive, then this will be plus infinity. If L is negative, this is negative, then that will be minus infinity. If you have an L over infinity, that will go to 0. Okay. Now, if you remember this, we did it with 2.3. I need the last one. This is exactly what I'm looking for. If I have non-zero over 0, if I have non-zero over 0, then what I will do, then we call it infinity category first. It's infinity category. And they have 3 cases, 3 possibilities. 3 or 4, 3. Yeah, the fourth one, the third and the fourth are the same. F. The limit, I check the limit from the right. If it is equal, the limit from the left, and equal to infinity, so say the limit as this goes to a equal to infinity. Example, 1 over x squared. As x goes to 0. As x goes to 0. It will be infinity from left, infinity from right, and it goes to infinity. This is the first case. The second case, the other way, if I'm going to from right equal from left, but now it's going to minus infinity. So what will happen? The limit as it goes to a, that will be minus infinity. Okay. And example, f of x minus 1 over x squared. Okay. The third case, let me write it here. If the limit as this goes to a equal infinity, but the limit as this goes to minus a from the left, I mean, a from the right is infinity, but minus from the left is minus infinity. Or from right minus infinity and from the left goes to infinity. They're not the same. We say the limit is goes to a does not exist. I cannot say it's infinity or minus infinity. I would say the limit does not exist. But note, in all these three cases, x equal a is a vertical asymptote. Since I need only one statement. Here I have x equal a is a vertical asymptote. Here I have x equal a is a vertical asymptote. Yeah. Okay. An example for this one, 1 over x. From right goes to infinity, from left goes to minus infinity. Okay. Now we'll go to some questions. Yeah. This is just the statement. X goes to 4. X goes to 4. It's not 1. It's 2. So this is 2. X goes to minus 3. Left, not equal right. Right, I mean not equal left. So this is does not exist. So this is wrong. X goes to 1. 1 is not 0. 1 is a value there. So it's not 0. X goes to 0. As x goes to 0 from left or from right, I'm going to plus infinity. So this is correct. It goes to minus infinity. It goes to minus 1. This is minus 1. So D is the correct one. So I give you a graph and he put some statement. Which one is correct? Okay. Now look at these questions. What shall I do? Yeah. First, you need to think of it this way. If we substitute, I have non-zero over 0. Directly, this is infinity category. And since I'm doing it from left, so either my answer is minus infinity or plus infinity. There is no other answer. How to check it's plus or minus? I need to do it through the signs. So let me write it and check the signs of each statement as x goes to minus 2 from left, as it goes to minus 2 from left. My result, for sure, it will be infinity or minus infinity. Okay, now check the sign. This one, as this goes to minus 2 from left, that will be negative. Minus 2 from left, this is negative. Minus 2 from left, also this is negative. That will be minus 2.001. So it will be negative, negative, negative. So the answer is minus infinity. This one. Sometimes you need to simplify the function before you conclude. So I check limit. No, this is x goes to 1, huh? X goes to 1. It's not right or left. This is what I mean. So I simplify this. X minus 1. X squared plus x plus 1 over x minus 1 times x minus 1. X minus 1 all squares. I can cancel this x minus 1 with this x minus 1. I'm getting what? Limit x goes to 1. X squared plus x plus 1 over x minus 1. Okay. Now, if you look at this one, it is non-zero over 0. So it's infinity category. Note, and by the way, here I wrote minus infinity and infinity because it does not exist because it goes to from left or right. Huh? Now, if you remember, in these three cases, as x goes to a, either it goes to infinity or minus infinity or does not exist if left not equal to right. So I need to check left and right and see what will happen for this one. So check the sign. It's infinity category. So from right for this one, what will happen? This one from right, always positive. Positive, positive, positive. That's it. This one, also positive. One from right. So this is will be plus infinity. However, if I do limit x goes to 1 from left for the same one, what will happen in the numerator? Still, it's positive because 1 from left is 0.999 something. So this is positive. This is positive. Add 1. So this is positive. But this one, 1 from left, 0.99 minus 1, that will be negative. So I'm getting minus of it. That means what? Right not equal to left. So that means the limit is goes to 1 for this function does not exist. So the answer is does not exist, which is the same function as this, except that one. Okay. Yeah. Now, yeah, this is not related to infinity, but since he wrote there, which is wrong. Yeah, actually, what you will do, you can take care of this absolute value of the x minus 2. So I need to check the limit from right. It's talking about x equal to. Because from right, it will be x minus 2, and from left, it will be 2 minus x. For this function, so I need to check, will that make a difference or not? That will be x plus 3 times x minus 2. From right, so this is positive. So this is x minus 2, as is, cancelled. I'm getting 5. But if I do go to 2 from left, from this, so this is negative. So that will be limit is goes to 2 from left, x plus 3 times x minus 2. If I get rid of the absolute value, that will be minus x minus 2. This is cancelled. I'm getting minus 5. So they are not the same, so the limit does not exist. Yeah. Now, this one, minus 5 from left. First, if we substitute, you have minus 5 plus 3, then 0. In the numerator, in the denominator, we have what? 25 minus 40 plus 15, which is 40 minus 40, which is 0. So it's infinity category. Now I need to check it's plus or minus. So I need to do it through the signs, or I can simplify it. This is x plus 3. X plus 5. I can cancel this because x cannot be equal minus 3. And then check the sign of the result. As x goes to minus 5 from left, so it's minus 5.001. This will be plus, but this is negative. So I'm getting what? Minus infinity. Yeah. Square secant by x. Yeah. Yeah, you can do this. Change it into cosine. That will be cosine by x. Now, if I substitute, I have non-zero. What is cosine by over 2? That will be 0. Non-zero over 0. So it's infinity category. I need to check the sign. Is it plus or minus? This one always positive because x is squared. I have half from left. Okay, now half from left. Let me do it in steps. Half, or x goes to half from left. Less than half. By x will go to where? Pi over 2 from left. Pi over 2 from left, which quadrant? That will be the first quadrant. Where cosine is what? Where cosine is positive. So this will be positive. So my answer will be plus infinity. And that will be that. This one. Yeah. When you have 1 over x, this is the graph for 1 over x. You need to be careful. As x goes to 0 from right, I'm going to infinity. Goes to 0 from left, I'm going to minus infinity. Yeah, so x goes to 0 from right. 1 over x will go to plus infinity. X goes to 0 from left. 1 over x will goes to minus infinity. And then I'm applying e to the power. So e to the power 1 over x. I know the graph of e. As the argument goes to infinity, e goes to infinity. So this is goes to infinity since the argument, which is 1 over x, goes to infinity. However, here, as minus infinity, as this goes to minus infinity, the value goes to 0. This is goes to 0. It means what? It means when I need to deal with the limit from left and right. From right, that will be 1 plus 0 over 1 plus, yeah, from right, it goes to what? Infinity. This is infinity. So 1 over infinity, give me what? 0. If I have the left, now e to the power 1x goes to what? To 0. So this is will be 1 plus 0 over 1 plus 0, which is 1. They are not the same. So the limit is goes to 0 of this function does not exist, which is this one. Okay. 1 over x minus sine 1 over x. What shall we do now? Yeah. I know that sine 1 over x is between minus 1 and 1. So it's a value bounded between minus 1 and 1. Okay. So this is this limit, and I know that the limit as sine 1 over x, as this goes to 0 from right, does not exist because it will isolate. I don't know where it will stop. Does not exist. So this is a value between minus 1 and 1, but I don't know it will reach what. However, if we deal with the limit x goes to 0 from right, for 1 over x, this is plus infinity. So this is goes to plus infinity. This is goes to a value. It does not exist. The limit does not exist, but it will be a value between minus 1 and 1. So I have my plus infinity, and I subtract from it a value between minus 1 and 1. So for sure, that will not affect the infinity. So the result of all of this, so this limit goes to plus infinity. Since I have infinity minus a value between minus 1 and 1. I don't know what is it, but regardless, infinity minus that value, for sure I'm getting infinity still, because it's a value, it's a small value between minus 1 and 1. Okay. Now we'll talk about the horizontal, the vertical asymptotes. As I said, the vertical asymptotes comes from where? Comes from, if you remember, comes from the zeros of the denominator, if I have rational function. And you need to check that the numerator is not 0. So you have non-zero over 0. Okay. Let me check now. Now, I can simplify this one so I can see it easily. Yeah, this one is what? Minus 2 x squared. No, yeah. How to simplify this? Minus 2x squared. Let me take the minus x squared plus x minus 1. So maybe that will make it easier for me to do the calculation. This is minus what? 2x. X. I want this plus. So this is plus 1. This is minus 1. Okay. Now, the possible vertical asymptotes are what? X equal half or x equal minus 1. Note for x equal half, note for x equal half, what is the value of the numerators? Call this f, call this g. These are the zeros of g of x. Okay, what is f at half? It will be half minus 1, half plus 1. Not 0. For sure, x equal half is a vertical asymptote. Done. I am done with this. Now it comes to x equal minus. If you check f of minus 1, it will be 0. Because if I put it there, it will be minus 2 times 0, so it will be 0. If that means it's not a vertical asymptote, we don't know. What I need to do, I need to find the limit. X goes to minus 1, either from, minus 1. Okay. Minus 1 for this one. Yeah, I notice in x plus 1 will be cancelled. So I'm getting a value. It will be minus 2 over minus 3. So it will be minus 2 over 3. The more important is not infinity or minus infinity. That means x equal minus 1 is not a vertical asymptote. Another way to think of it, just if we cancel this, assuming x is not equal to minus 1, then I have x minus 1 over minus 2x minus 1. So the only things which will make vertical asymptote is x equal half. So this is my answer. So I can do this. I can say f of x minus 3, x minus 1 over x minus 4 times x minus 1. I can cancel x minus 1. So I have a whole at x equal 1. Okay. So that means the only vertical asymptote remaining is x equal 4. And it will be a vertical asymptote because it will be, this is 0 and the numerator non-zero. So x equal 4 is a vertical asymptote. Same thing, we'll do the same thing. I'll just simplify it. Take x. I have what? X squared minus 3x plus 2 over x times x plus 1. That will be x minus 2 times x minus 1 over x times x plus 1. I can cancel x with x, and this is the remaining. Means what? X equal minus 1, A is a vertical asymptote. Because I have non-zero, it will be non-zero over 0. If I do the limit. So I have only one vertical asymptote. This one, same idea. I have x minus 2 times x plus 1 over x minus 2 times x plus 2. This is cancelled, provide x not equal to 2. So I have vertical asymptote only x equal minus 2. Because at x equal 2, I have a whole. Because it will be non-zero, and this is non-zero. If I put minus 2. The same idea, but now it's a little bit complicated. 4x squared plus x minus 6. Here I can do it by grouping. Group this with this. I have x cubed, x minus 2, minus 9x, x minus 2. So that will be 4x minus 2, x plus 3, over, I have what here? X cubed minus 9x times x minus 2, 4x minus 2, x plus 3. Here I can take x. I have x minus 3 times x plus 3 times x minus 2. Yeah. Okay. Now, if we look at it, that means what? This is will be cancelled, and this is will be cancelled if x not equal to -3, if x not equal to 2. And how many vertical asymptotes I have? 2, which comes from here and comes from here. X equals 0 and x equals 3. At 2 and -3, I'm getting a hole. So I have 2 vertical asymptotes. The number of now, if I have len, then there is a change in the possible vertical asymptotes will come from 2 places. Will come from the zeros of the denominator and the zeros of the argument of len. Which is this one. So I have the possible, this, give me x equals 0. These are the possible ones. And this, give me x equal 2. And this, give me x equal -2. Okay. Now for this one, I can do check the numerator. What will be? It will be len of -2. Oh, there is a problem with this one. So this is cannot be a vertical asymptote. However, here I have len 2. So I have non-zero over 0. But this is 0 of the denominator. So for sure I have x equal to is a vertical asymptote. And you can do it through the limit. For this one, x equals 0. And notice limit x goes to 0 from right of len x. This one, if you think about the len, if you remember the len, this is the len. As this goes to 0 from right, len x goes to what? To -infinity. So this goes to -infinity. And this goes to a value, -2 times 2. So I'm getting what? +infinity. So x equals 0 is a vertical asymptote. So how many vertical asymptotes we have? 2. X equals 0 and x equals. Now, more about the len. I need the possible are the argument of the len, the zeros of the numerator, the denominator, I mean, and check. Now, if x equal 1, I have len of -1 undefined. So I have a problem. This is not a vertical asymptote. -1, also it's -3. So this is undefined. So this is not a vertical asymptote. The only possible ones is this one. And check the limit as it goes to 2 from right of len x -2 over x -1, x plus 1. This is goes to -infinity. This goes to a number, which is 1 times 3. So the answer is -infinity. So x equal to is a vertical asymptote. Another one with the len. Yeah. We'll find, yeah. Almost there. Another one with the len. The same thing. The possible ones are this. I have x equal -3, and I have x equal 2. For x equal 2, I check the numerator. It will be len of 2 plus 3, which is len 5. Okay, so x equal to is a vertical asymptote. But this is defined. For this one, I need to check the limit. Actually, for sure, the numerator will goes to, this is will be len of 0 plus, which is goes to -infinity. So I have -infinity, or do it with another color. This is goes to -infinity, and this is goes to -5. So the answer is infinity. So x equal -3 is a vertical asymptote. So how many vertical asymptotes? We have 2. 2 vertical asymptotes. Okay. Now I combine many things. Okay. So this one, I can simplify it. X plus 1, then x plus 1 over x plus 1 times x minus 1. So this is cancelled. Okay. Now the possible vertical asymptotes are coming from where? Here I have x not equal to minus 1. I have x equal 1 comes from here, and from there I'm getting x equal minus 1. Now, if x equal 1, is it a vertical asymptote? Check. Substitute the numerator. I have ln of 2, which is okay. So x equal 1 is the vertical asymptote. Now, for x equal minus 1, I need to check the limit, which will be, this is minus infinity, and this is just a number. So for sure it will be an asymptote. I have minus infinity. This goes to minus infinity. This goes to minus 2. So I have infinity. So x equal minus 1 is also a vertical asymptote. I have two vertical asymptotes. Yeah, this one. I have the possible ones. Comes from here. X equal 1. There, x equal minus 4. The argument of len, I have x equal 2 and x equal minus 2. Check the numerator for x equal 1. I have len 1 minus 4. There is a problem. Len minus 3. This is out. So this is not vertical. X equal minus 4, but the len will be what? 16 minus 4. So it's okay. So this is a vertical asymptote. X equal minus 4 is a vertical asymptote. This is not equal to 0. Now, for x equal 2, it comes from here. So for sure, these are values, but this will go to minus infinity. And this goes to minus infinity. I take the limit. This goes because I want it to be positive from the right. Now let me do it here. I need to find the limit. This goes to 2 from right. Then x squared minus 4 over x minus 1, x plus 4. That'll give me what? This one goes to minus infinity. This one goes to 1. This one goes to 6. So the answer is minus infinity. So for sure, x equal to A is the vertical asymptote. And the same thing here. Since I have minus infinity for the len, and these are just the numbers. So I have 3 vertical asymptote. So this is also is a vertical asymptote for the same reason. So I have x equal plus or minus 2 and x equal minus 4. Okay, now with sine and cosine. I need to check how many vertical asymptotes. This argument will not make anything for me, but the possible ones are x just comes from the denominator. Now I need to check what will happen. This one, if you do the numerator, I have sine minus 1, which is a value, not equal to 0. So for sure, x equals 0. A is the vertical asymptote. Okay, what about this one? X equal minus 1. If we check, it will be sine 1 minus 1, which is 0. So we cannot conclude. So I need to check the limit now. This is we cannot conclude. We said if it is not 0, then we are sure it's a vertical asymptote equals 0. We don't know. So I need to check the limit as this goes to minus 1 of this function. Let me do the limit here, but it needs some calculation. Limit x goes to minus 1 sine x squared minus 1 over x plus 1. Yeah. How to do this? I need to have the same argument of this. So I multiply. This is x minus 1 times x plus 1. I have x plus 1, so I multiply by x minus 1. So I have x plus 1. I multiply it. And here I have sine x squared minus 1. So I have multiplication by x minus 1. So this limit will give me 1. Why? Because if you think about it, limit x goes to minus 1 sine x squared minus 1 over x squared minus 1. Now, if I let t equal x squared minus 1, this limit will be limit sine t over t. Now, if x goes to minus 1, x squared will be 1, 1 minus 1, so t goes to 0, which is 1. So this is goes to 1, and this is will be 1 over minus 1, which is minus 1. So x equal minus 1 will not go to infinity. So it's not a vertical asymptote. So how many vertical asymptotes we have? Only one. Yeah. What's sign again? Okay, let me simplify it. X 2 sine x cosine x over sine square x. And that give me what? 2x cosine x over sine x, provided no sine x not equal to 0. As a limit, I can do this. Okay. Now, he said which one is false? If it's discontinuous at x equals 0, yes. What is the limit as it goes to 0? I don't know. I need to check. So what is the limit as it goes to 0 for this function? Will be the limit as it goes to 0 to x cosine x over sine x. This is what? This is 1, and I have 2 times 1 over 1, which is 2. So this is correct also. So these are correct. I want the false instead, by the way. Okay. Now, I need to check the limit for 2 pi and 0. For 0, I'm getting a value. So for sure, there is no vertical asymptote. So this is for sure wrong, which is I'm looking for. For pi, what will happen? Limit x goes to pi 2x cosine x over sine x. Now, if you look at it, this is non-zero, and the denominator 0. Because it will be 2 pi cosine pi. Here it will be 0 over 0. Huh? So because of that, I need the limit. Here you do the limit, you have non-zero over 0, so x equal pi. A is a vertical asymptote. And the same thing for 2 pi. So these are correct, except that first. The sum of all k's right. Sum of all k's for which x equal k is the vertical asymptote. So I think about f of x secant by x over 2. Or I can rewrite it 1 over cosine by x over 2. So when I have vertical asymptote, because it will be non-zero over 0, if cosine, I have vertical asymptote, if cosine by x over 2 is equal to 0. Okay. So I have x equal a is a vertical asymptote. If x equal a, so cosine by a over 2 equals 0. When cosine an argument is equal to 0, if that argument is equal pi over 2 plus n pi. Because you know pi over 2, 3 pi over 2, 5 pi over 2, all of this cosine of that value will be 0. And the same thing in the negative side. Now do the calculation. I need to multiply by 2 over pi to find a. So this is what I'm looking for. I'm looking for the vertical asymptotes. A equal what? 1 plus 2n. But this is what? These are the odd numbers. And they have this interval between 0 and 6. 0, and 6. I need, these are the integers. I'm looking for a value, integers, huh? 1, 2, 3, 4, 5. Actually, I need the odd integers. The odd integers. So I need the 5, the 3, and the 1 between 0 and 6. So it will be the sum 1 plus 3 plus 5, which is 9. So this will be my answer. The number of vertical asymptotes for this function, x over tan x. Sometimes change it into cosine, it will be easier. I have x over, this is sine over cosine, so I have cosine here and sine here. When this will make a problem to me, if I have sine x equals 0. Possible? Here, I am sure they are vertical asymptotes because the numerator is 1. It's a non-zero. So just I need the denominator to be 0. Here, maybe the numerator is 0. So I cannot say this is for sure. I need to check. This is the possible ones. Sin x equals 0. When sin x equals 0, معناها x equal what? N pi. If x equal N pi. So in this interval, what are the values which I consider? So I have x equal minus pi, x equal 0, x equal pi. Just put in minus 1, 0, and 1. Because other than that, I will go outside this interval. Now I need to check these. The limit goes to infinity or not. This one, the limit will not go to infinity, which is easy to check. Because I know that one goes to a value, goes to 1. Cosine 0 is 1, so this limit equals to 1. So x equals 0 is not a vertical asymptote. However, for x equal minus pi, the denominator will be 0, but the numerator will be minus pi cosine minus pi, which is not 0. So for sure, x equal minus pi is a vertical asymptote. And the same thing here, which implies x equal pi is a vertical asymptote. So how many vertical asymptotes we have? 2. And this is the number of vertical asymptotes. Which of the following functions has a vertical asymptote at x equal 1? Okay. I need to check them one by one. Let me do it. I need to do the limit for all of this. If the limit goes to infinity or minus infinity, it means we have vertical asymptote. Otherwise, we don't have vertical asymptote. Okay, let me do it step by step. Limit x goes to 1 for f of x. That will be limit x goes to 1, x minus 1, x plus 1 over x minus 1 square. So this is cancelled, provided x not equal to 1. So that will be limit x goes to 1, x plus 1 over x minus 1. So I have non-zero over 0. So for sure, x equal 1 is the vertical asymptote for f. Now check g. Limit x goes to 1 for g of x. That will be limit x goes to 1, then x minus 1 squared over x minus 1, which is limit x goes to 1, then x minus 1. I'm providing x not equal to 1 since I'm dealing with the limit. Now this one, I know x equal 1 is a vertical asymptote. Because I know how to graph it. This is the graph of this one, just a shift at 1. This is the length. So for sure, x equal 1 is a vertical asymptote. Now let me do h. What will happen? Limit x goes to 1 to h of x. Will be limit x goes to 1, x plus 2 times x minus 1 over x minus 1. I'm getting a value here. I'm getting 3. So x equal 1 is not the vertical asymptote here in this case. The fourth one, limit of p of x as it goes to 1. That will be limit as it goes to 1 tan inverse of 1 over absolute value x minus 1. So if x goes to 1, x minus 1 goes to 0. So I'm getting 1 over absolute value x minus 1. Will go to infinity. It will be, yeah, because this will be positive, and positive goes to infinity. That means tan inverse of this will go to pi over 2. It's not infinitesimal. It's going to a value. So this limit equal pi over 2. So that means x equal 1 is not a vertical asymptote for this function b. It's not here, it's not here, it's here, there, and there. So this is the value. Okay, the same thing. We have different functions. Let's check when the x equal 2 is a vertical asymptote. Check the first one. Limit x goes to 2 of this. Very clear. This goes to minus infinity. It's just a value. This is just a value. So this will be minus infinity. Positive values. It depends on C. If C is positive, so C is positive always. Oh, that doesn't make a difference because C minus infinity is minus infinity over 4. So this will be infinity, minus infinity. So x equal to A is a vertical asymptote in this case. Now let me check G. Limit x goes to 2, sine x plus C over x minus 2 square. This for sure it will go to infinity. Why? Because if I do the sine is between minus 1 and 1, I divide by, yeah, that will not help. Yeah, no need. Yeah, actually this will be, if I substitute 2 plus C and C these numbers, so for sure I'm getting non-zero over 0. Because it's impossible to have this is to be 0 because it needs pi. 0 pi, 2 pi, 3 pi, which is impossible to be that. So for sure x equal to A is a vertical asymptote. Now the last one, with s goes to 2 of h of x, which is 8 minus 4x over x cubed minus 8 plus c. Yeah, I need to simplify the first expression. 4, I have 2 minus x. Here I have x minus 2 times x squared plus 2x plus 4 plus c. This is cancelled. I'm getting minus 1. Now I can do the limit. It will be minus 4 over what? 4 plus 4 plus 4 over 12 plus c. What's important is not going to infinity or minus infinity. That means x equal to is not a vertical asymptote. So it's there, but not there. So this will be my answer. Yeah. I have these true or false. He wants the true ones. He agreed no x equal a the vertical asymptote if any of these 6 cases agreed. So this is vertical, this is true. If the limit equal the limit, this is continuity, not differentiability. So this is wrong. If the both limit does not exist, doesn't mean their product does not exist. No, we cannot conclude this. This is wrong. This is 0, not minus 1. Is this one continuous on this interval? No. Why? Because at minus half, you have 1 half minus half. That is 1. Yeah. It's continuous in this interval. Why this is wrong? Because what will be the limit as this goes to minus half from right? Actually, we cannot discuss it from left. So for sure, you cannot talk about minus half to be continuous or not. Oh, I can't discuss it from left or right. Yeah, from right, that give me what? That give me from right minus half from right. I need to discuss it only from right on this side, which is minus 0.44 something, 0.5. That will be, if this is less than half, less than minus half, huh? This is minus, yeah, I can think of it, minus 0.49999. Plug it here, 0.5 plus 0.499, that will be 0. Yeah, because it will be half minus x will go to approximately, it will be minus 0.9999. So the greatest integer is minus 1, not 0, sorry, is minus 1. What will be f of minus half? It will be greatest integer half minus minus half. And that give me what? Sorry, this is half minus minus. So this is plus, sorry. So this is plus. The x is minus 0.99. So I have plus 0.499. That will be plus 4.999. That will be 0. But the greatest integer, it will be half plus half. That will be 1. So they're not the same. So if it's not continuous at x equal minus half. So this is the only the true statement. Which one of the following statement is false? I want the false statement. The graph of every rational function has a vertical asymptote. No, this is wrong. Why? Take this function. This is a rational function. Make it x over x squared plus 1. But there has no vertical asymptote. But this is impossible to be 0. The graphs of polynomial function have no vertical asymptote. Correct. The graphs of polynomial functions may have vertical asymptotes because tan and cosecant, secant, they have vertical asymptote. Because of that, we say may have, sine and cosine, no. The graph function cannot cross a vertical asymptote, yes. The graph rational function may have several vertical asymptotes, yes. May have several vertical, not only one. And actually, we saw cases where you have 2, 3 vertical asymptotes. Yeah, I will stop here. I think it will be good for this section, 2.5. I will stop the recording. So I will go to the recording. I will stop the recording now. Thank you.